Let's see how screen sharing works in testRTC. We'll go in the dashboard to my tests. There is an appearing screen sharing sample here that we've created. First things first, appearing runs as a mesh service in this case with 4 concurrent users. In the run options, we added a few things that we must in order to support screen sharing. The most important part is this, the extension, where we have a tar.gzip file of the Chrome extension of appearing. And we need that in the browser installed so that we can actually do screen sharing with Chrome. Now, if you look at the script, we added a video URL here. I've taken one with this TV prefix so that it goes full screen and selected an arbitrary film trailer. After that, when we go to the clients themselves and what they do, the first agent opens up the URL, goes into it, everything is as it has been done always, and then to the part that is interesting. We click in the UI on the button that starts screen sharing for appearing. Then we call RTC event to show it, to visualize it in our graphs in the end, we'll see it later. And then we start taking screenshots. We execute this command, which essentially opens a new browser tab in the first agent. And this tab is going to show the video from YouTube. Then we wait a bit for 5 seconds here, and we switch to that tab. Okay? Later on, we will switch back. The rest goes on as usual. We have 2 types of browsers here, both Chrome stable, both from West US, one with 720p video and one with 1080p, just so we'll have some variance on the screen. Let's run the test and see what happens. We're not going to wait for it from beginning to end, so let's fast forward. And we're done. Now let's review the results that we've got. So there's a warning here that I'm going to just ignore. This is a high-level chart of everything. You can see that everything was stable here. Let's remove the min-max bands. And things got a bit jittery over here. This is the event, the time where we started screen sharing, and if we had the add the min-max band for all 4 browsers, we can see the variance between them. Let's look at what happens in the first browser, in the first agent, the one that actually started screen sharing. So the results are in. This is the first agent. Let's see the media files. These are images that we've took through the session. We can see at the beginning, we've got 4 different participants. Then we start screen sharing. And we've got this nice recursion going on here for us. And then we switch to the other tab and we just show the movie. So you can see images from the movie. This is appearing, so we've got a mesh service for 3 incoming and outgoing media channels in each direction for 4 participants. Let's go and see what happens on the video side. Now these are the video graphs. What I want to show you here that is interesting, let's first shut down all of the incoming stuff. So now we see only the outgoing channels. We have three outgoing video channels. This is a straight line, and then it starts fidgeting. This is a screen sharing part. And the interesting thing is that appearing uses the same channels to do screen sharing as it does for the video call itself. Let's go back and look at some other probe instead. Let's look, for example, at probe number 3, which was on the receiving end, one of the people that saw the screen sharing. Agent number 3. If we go and look at the media files on this one, we can see 4 participants, and then again, we move towards the movie. This is the shared screen from the other browser. And again, we can review it. We can look at the analysis of the graphs. In our case, if we go to the video graphs, this incoming stream is the one that does screen sharing. You can see that the number of packets is also different, and that frame rate drops from something like 28, 29 frames per second to around 2 or 3 frames per second. And that's it. You can do it at scale, and you can use testRTC to automate your screen sharing testing.